Hey everybody, today's lesson is on cumulative frequency and box plots. Mixture, foundation and higher in here, and I'll identify which for you. Cumulative frequency we did last year in NICATs, and this year we're going to go back and have another duke at it, and then throw in a couple of additional layers in of the top. So, what is cumulative frequency and what the hell are these box plots and what are we talking about? So we've been looking at an awful lot of graphs recently. Over the past couple of weeks, and you've been finding them okay. People have been able to draw them in class and put them together. And of course, the tough part's going to be when we put it all together. Which goes with which, and how do we represent that data in a certain way, etc., etc. In most cases, in the exam for yourself, though, you will find out that it will tell you what it wants you to do, which is always a good thing to do. So, cumulative frequency and box plots. What is cumulative frequency? So, cumulative is just a password of saying add up as you go along. And frequency is just a password for total. So if you put the two of them together, you get a very posh way of saying add the totals up as you go along. So let's take an example. So to the right is a table showing the length of time a group of 40 students spent playing on a Nintendo Week on a gloomy week in January when they're supposed to be revising for the exam. It asks you to draw a cumulative frequency curve, use it to estimate the mean and enter the quartile range, and construct a box plot. So in the table on the right, it shows you the hours they spent playing and the number of students that happened to. So between greater than 1 or greater than nothing and less than or equal to 1 hours, there were 2 students. Greater than 1, less than or equal to 2, there's 5. Greater than 2, less than or equal to 3, there's 10. Greater than 3, less than or equal to 4 is 15. Greater than 4, less than or equal to 6 is 5. And greater than 6 and less than or equal to 10 is 3. First thing we need to do, as it says there, is add a cumulative frequency column. Okay, so before you can even start thinking about drawing the graph or the curve, you need to be able to add a cumulative frequency column to your frequency table. So remember, cumulative frequency is just a fancy way of saying that you add up the frequencies as you go along, and it's sometimes called a running total. So what do we do? We add this total to the right, and it explains as such. So the first figure 2 is the number of people who play for 1 hour or less. So as you can see here, if this is the people that spent up to and including 1 hour, there's 2 people, then that's 2. The next one, 7, is the number of people who play for up to 2 hours. So it includes the people that played for 1 hour and the people that played for 2 hours. So it's 2 plus 5 is 7. And what you keep on doing is adding on these values. So up to 3 hours is 17. Add on 15 for up to 4 hours to be 32. Add 5 on to be up to 37, etc., etc. And that's what we do. Now, we're going to plot cumulative frequency, but what do we plot it against? We'll plot it against, I should say, before I skip on, the last entry is the total number of people. And so if, for instance, the question says that there are 40 students and you don't get 40 here at the end, you know there's a mistake somewhere in the question. Either the question's wrong or you're wrong, and you can fill in to see which one of those is more likely. So we're going to draw the curve. And remember, we'll plot cumulative frequency against what? So we plot against the upper bound. So we'll do it as if it was conversational. So there was 2 people who played up to 1 hour. There was 7 people who played up to 2 hours. 17 people played up to 3 hours. Remember that up to 2 hours means that it's from 0 to 2 hours. Up to 3 hours is 0 to 3. Up to 4 hours is there. So we will plot our upper boundary, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember to be consistent against our cumulative frequency. So on the x-axis you're going to plot 1 on the x-axis and 2 on the y, 2 on the x-axis, 7 on the y, etc., etc. So it's important. So we did frequency polygons last 2 weeks ago, and I told you when we were doing frequency polygons that everything is drawn with very sharp lines. Well, a cumulative frequency curve is called a curve for a reason. We're drawing it up with as smooth a curve as possible so it kind of flows. And the curve starts at 0 because it's assumed that there are no people playing at less than 0 hours a week. Okay. You must label your axis correctly or you will lose very easy marks, and that's always so true in all these graphs. Title on the graph and label your axis as well. So what does it look like? So we're going to plot our points here, and it looks a bit like this. So there's our 1 and 2, 2 and 7, 3 and 17, etc., etc. And most cumulative frequency curves will look something like this. They will have what we call an S shape. People often wonder what happens here. Well, we've reached the 40 people. That line will continue on straight along the 40. Doesn't tail off, doesn't do anything else, just goes there. So that's our cumulative frequency curve, right? And we did that last year. For axis label, time spent playing the Wii in hours, and the cumulative frequency up the side. So we're going to estimate a thing called our interquartile range and our median. And if you think back to what the median was, the median is the middle value. So the way we'll treat this is, if there are 40 students, then the person that's going to be halfway is going to be the 20th student. So we would go to where our 20 is in our graph. In fact, it's going to show it on down here. And draw a horizontal line and sort that out. So what does that look like? So I'm going to go back and forward. So we go to a 20 and we go to the right and we go down. So there are 40 students and we'll go to the half of that, 50% of the way along, and we'll go right and down. If there had been 80 students, we would go to 40 students because that's halfway along and go right and down. And that's the median. Now we have to find out two other bits of information, and again this is a recap of last year. We're going to find the upper quartile and the lower quartile. And the upper quartile is the point where, I'll just get this on, the upper quartile is there. It's 75% of the way along, or half of that again, 75% to 3/4. And if you're having trouble, there can be a formula. 3n divided by 4 will give you the upper quartile. So n being the number of people. So if I do 3 times n, so 3 times 40 is 120, divided by 4 is 30, and that will give me the amount of people there. And if you look at it there, 30 right and down is 3.8 hours. Lower quartile, rather unsurprisingly, is the lowest quarter, 25% along. You could find 25% of 40, or you could do n divided by 4. So it's the number of students, 40, divided by 4, which would give me 10. And if I do the 10, I will get, draw across and draw down, I've got 2.4. So our interquartile range is the difference between our upper quartile and our lower quartile, a bit, range as we said before, and you get 3.8 to minus 2.4. And this is a recap of last year. Remember, the median is a form of average, and just like the range, the interquartile range is a measure of consistency. Now, I talked about that some last week when we were doing interpreting ranges and averages. That is about how consistent the data is, rather than being a measure of average like mean, median, or even mode. Right? So we'll come on to what this consistency and stuff means, because it's quite important when comparing sets of data. So that's one way to show information on a cumulative frequency graph, but it's a little cumbersome. We'll have to draw the graph, we'll have to work at the cumulative frequency, draw the graph, then work out our values there and there, and go like that. It would be much nicer if there was a nice, more simpler way to express it, and of course there is, and it's called a box and whisker plot, or a box plot sometimes. So if, as it says here, if you have the chance, draw your box plot directly below your cumulative frequency graph using the same scale on the x-axis. You can just extend the vertical line downwards and save yourself a lot of times. So this is what a box and whisker plot looks like, okay? And I will try and point out that there are 5 measurements in it. 1, follow the cursor, 1, 2, 3, 4, and 5. So we'll go through each of the 5. And we're going to go left to right. So we have the lowest value is on the left. So the very lowest value of your data range goes on the left. The lower quartile is next. So the value for the lower quartile goes there. Next comes the median, and that goes in the middle there. Upper quartile goes there, and the highest value goes there. And this bit between the difference between the upper quartile and lower quartile is known as the interquartile range, just like we said. The entire range is the difference between the lowest and the highest value. So just be careful when it's asking you for either the range of values or the interquartile range. Note the minimum value is the lowest possible value of the first group, and the maximum value is the highest possible value of the last group. Okay, so this is what our previous one looked like. And look, we had a minimum value of nothing and a highest value of 10 hours. We had a median of 3.2. We had a lower quartile of 2.6 and an upper quartile of 3.8. Our box and whisker plot looks like this. It's drawn on graph paper as before, but it looks like that. So you have your lowest value there, your lower quartile, your median, your upper quartile there, and it goes there, and we'll label our graph exactly the same along the bottom. So the time spent in hours is still going along the bottom, and it's very much like for like. And that is a box and whisker plot with which we will practice lots and lots. In fact, we'll practice lots of drawing the cumulative frequency and what that looks in a box and whisker plot. So I'll go over some of the vocabulary we had there before. Median, which should be familiar to you, is the middle member of a set of data. And with the upper quartile is the median of the data values that are greater than the median of the total data set. So it's like the middle of the upper middle, and the lower quartile is the middle of the lower middle, or a quarter of the way along. Upper and lower extreme is the highest and lowest numbers in the data set that you have. So the upper value and the lower value, and those are the values you'd use to work out the proper range. So the biggest value overall, take away the lowest value. Can we draw these box and whisker plots without drawing a cumulative frequency? Well, we can. It's a bit more tricky, but we use a lot of the same principles that we use when working out median and other things like that. So we've got to make a box and whisker plot using the following set of data. So 1, 6, 10, 4, 2, 8, 15, 6, and 3. So the first step, as we do with any median, is put the numbers in order from smallest to greatest. And if I do that, I get 1, 2, 3, 4, 6, 6, 8, 10, 15. Next bit is we're going to create a number line so it extends beyond the upper and lower extremes. So we're going to go slightly lower than 1. We're going to go slightly up bigger than 15, and this one's been drawn from -5 to 20, which is quite reasonable. Third bit is to find the median. So to find the median, we find the middle value. And you can do your stroking off from this top and the bottom. So one from the top, one from the bottom, one from the top, one from the bottom. You'll find that it's the middle number in this case is 6. And there's 4 values that side, 4 values that side. We draw a line above the median on the number line, so we would draw a line above the 6, like so. If we're looking for the upper quartile, we're looking for halfway in the bit above the mean, or the median, sorry. So halfway up here is actually going to have taken 2 values with 4 values above. The 2 middle values are going to be 8 and 10. And when we've got 2 values of a median, we find halfway between the two of those. Or 8 plus 10 is 18, divided by 2 is 9. And we'll put in our line for upper quartile there. Similarly for the lower quartile, we're going to have 2 values in the middle there. 2 and 3, halfway between 2 and 3 is 2.5, and we put our line in like so. Not much to do. We put a rectangle above the upper number line with the upper and lower quartiles as to the sides, so it looks like that. And then we'll put in our upper value, which is 15, and our lower value, which is 1. And these are called the whiskers. So you can see them in each line, and sometimes they're indicated with a dot on the end, or it could be a vertical line, and that is what your box and whisker plot looks like without looking at anything else. Okay, we didn't do a cumulative frequency diagram, we didn't do anything else apart from that. So that's our box and whisker diagram based on that data. So let's look at another one. There are 12 people in a habanero pepper eating contest to eat the following amounts of peppers. And there's their numbers of peppers they each ate below. So what do? We put it in order first. And if I put the data in order from least to greatest, it will look something like that. We then can draw a number line that goes below the bottom value and above the top value. It's all well and good. Now, as you might notice in this data set, there are 12 numbers. And when we have an even amount of numbers, we will get 2 numbers in the middle. So we get our two numbers to be 4 and 5, and the middle number between those is going to be 4 plus 5 is 9 divided by 2 is 4.5. Now this is where it gets a bit tricky. The median is actually now slap bang in the middle between those two numbers. That isn't our median there. They're the two numbers we use to help us find our median, but our median is slap bang in there. So there are 1, 2, 3, 4, 5, 6 values below it, and 1, 2, 3, 4, 5, 6 values above. So when we're looking at, there are that number of values below, that number of values above. So when we're finding our lower quartile and upper quartile, we're still going to have two values in the middle because we've got 6 values to take into account. Okay, so our upper quartile is going to be those two middle values, and the middle of those between 10 and 11, or 10 and 12 is 11, and it will go there. Similarly, below, the two middle numbers are going to be 2 and 4, and the middle of those is going to be 3. We will draw our box around those values, and we will put in our upper and lower whiskers of B0 and 18, and that would be that drawn. So be careful with that one, because visually if you write it down and you circle it and do it like that, it looks like there should be 5 numbers below the median and 5 numbers above them. But remember that the median is actually slap bang between those two numbers rather than those two numbers themselves. Just be careful if you're doing it like that. Okay, so I'm going to explain really what this means in all terms, what a box and whisker plot is, and it might make more sense then. So if I include the lower bounds to the median, this slot here makes up 50% of the data, and this bit here makes up 50% of the data. So that's your median there, so that's halfway, 50%. So that's 50%, and that's 50%, even if it doesn't really look like that. This bit here on its own, the upper quartile is from 50 to 75%, so that's 25%. That means that that bit there is 25% of the data up there. Similarly, that's 25% of the data, and the lower part of the box is 25% of the data. Okay, and when we're talking about how we're going to interpret these, we're going to talk about consistency and how spread out some of the data is within the thing. So just to recap, the interquartile range is the difference between the upper and lower quartile of a set of data. The upper and lower, our quartile range is the upper quartile, take away the lower quartile. So if I asked you to label this box and whisker plot with where you'd find the interquartile range, you would just throw a box around your upper and lower quartile, like so. Let's ask some questions of ourselves. Colby graphed some data is shown in the box and whisker plot below. Which statement is true about Colby's data? The first one is the range of the data is 25. Well, is that true? Well, the upper value is 95 and the lower value is 25, so the difference between those two values is 95 minus 25, which is 70. So that is not true. It says 1/2 of the data is below 65. Well, halfway in the data is this bit in the middle, it's the median, okay, and it's at 75. So it's not this line here, because that is the lower quartile. So from 65 to 25 accounts for just 25% of the data, or a quarter, not half. It says the median of the data is 60. It is not, it is 75, just like I said. And 3/4 of the data is below 90. Well, that one is true because the upper quartile accounts for 75% of the whole data, and it is at 90, and 3/4 of data is below that. So the answer is D. Pat yourself in the back if you got that right. Do one more. Again, you can pause it, have a look, see if you can get the answer before I continue on. So which of the following is not true about the box and whisker plot shown below? The interquartile range is 8, so we're looking for the thing that's not true. So the interquartile range, the upper quartile is there at 6, the lower quartile is at -2, the difference between 6 and -2, 6 take away -2 is 6 plus 2, which is 8, that is correct. The upper quartile is -2. Well, the upper quartile is actually +6, so that's not true. Let's check the other ones just to make sure. The median of the data is 1. Well, that's the line for a median there. It's at 1. And the lower extreme is -9 is correct. So the upper quartile is not -2. It is 6. And if you got that, give yourself a pat in the back. Okay, so what do we do when we're comparing box and whisker diagrams? Let's see. Box and whisker diagrams are very good for comparing data sets. And the following diagrams represent the rainfall in the first 16 days of March 2004 in 20 regions of the UK and of France. So there's your rainfall in UK, and your rainfall in France. And as you can see, there's lots of things different about them. Okay, you can compare the fact that if this is rainfall in millimeters on the bottom, there was the lower amount of rainfall is less in France, and it's greater in the UK than in France, and also the upper bounds is an awful lot higher than there as well. What else can you say? Well, the median rainfall was higher in France as well, because it's around a value of about 23, and this one is about 18. What else can you say? You can say the range of rainfall amounts is greater in the UK because it's about 76 and it's about 16. It's about 60. And here it's about 56 to 3. It's about 53. Okay, oh, that's just 6 rather than, so it's 70, sorry. And that one above. I knew that sounded a bit wrong. It's there and there. But the interquartile range is greater than France. So what can you say about that? As you can see, that box is wider than that one. So there's an awful lot going on in this bit here. The overall range of the values is massive. Look at that. But the actual spread of the middle 50% of the data is quite narrow. This one is an awful lot wider for the middle 50%. So what we can say is that the consistency of the middle 50% of the main of it is much more consistent in UK than in France as well. And this is where some of the confusion comes in with interpreting some of these. There are better examples that I'm saving for class, if you know what I mean. For when we're working through. I picked this one just because, you know, there's quite an awful lot in it, and you can see it very visually. But the better examples of like science experiments that we will do, we'll save for class. And if you're having trouble working out the consistency and what that means, don't worry about it. We'll get it. Overall, the range is biggest, but remember what each of these bits are. That's the lower 25%. That's the upper 25%. It's the middle 25%, lower 25%, the upper 25%, and that's your median in the middle. So in an awful lot of cases, you can say there's 3 marks, you will put in 3 statements, if you know what I mean, or something like that about what you can see. And in many cases, that will be what you'll get the marks for. But again, we'll practice that as we come along. And as it says there, we will discuss that the interquartile range is a better measure than range because it ignores extreme values. And extreme values are the likes of the ones we looked at in appropriate average. When we were saying about, you know, when working out what's the best average to say, sometimes there are values within our data set that are just way out of skew with everything else. So do we disregard all of our other results because one day in the UK it absolutely bucketed down from the heavens for one full day? Does that skew all the results out? It shouldn't. The interquartile range is what we would use, and it's what we use in scientific experiments or when we're testing theories and testing products, that kind of stuff. We would use the bulk or the majority of the middle data, see where it goes. If the data was skewed any further way the other way, we would certainly have to look at it, but we'd look for the reasons for it, and that's what scientists do. So I hope that makes some sort of sense this week. Good luck with it all, and I'll see you in class during the week. Any questions, you can send me an email. Alright, see you later. Bye. Box and Whisker diagrams. Let's see. Box and Whisker diagrams are very good for comparing data sets. And the following diagrams represent the real
Load up on guns and bring your friends. It's fun to lose and to pretend she's overboard and self-assured. Oh no, I know a dirty word. Hello, 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 hello. With the lights out, it's a dangerous I do best, and for this gift I feel so blessed. Our little group has always been and always will until the end. Hello, 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 with the lights out, is this dangerous? Here we are now, entertain us. I feel stupid and contagious. Here we are now, entertain us. A mulatto and a vino, a mosquito by the vino. And I forget just how I taste. Oh yeah, I guess it makes me smile. I found it hard, it's hard to find. Oh well,